Happy Halloween, everybody. This time of year is fun, dressing up in scary or silly costumes and sharing spooky stories by the campfire. We all know that stories are scarier when we think they're real. That's why every good campfire story says that it's true. But with campfire stories, it can be hard, if not impossible, to verify. If the only source is that long ago someone's great-great-grandfather claims to have seen a beast with glowing red eyes in the forest, how can you verify that? There's no documented evidence. There was only one witness, and who is no longer available to give his testimony. Unlike laboratory experiments, you can't run controlled experiments to test the repeatability of the occurrence. But with campfire stories, that's okay. It's fun to be spooked, and that's the point of it, to have fun. That's why we enjoy watching true crime shows, but don't enjoy being murdered. It's fun as long as you know you're not in any real danger. So when you're sitting around the campfire and Johnny tells a story about his grandfather seeing a mythical beast in the forest, it's not important to ask Johnny to cite his sources. Ensure that they're all credible, ensure there are enough experts in agreement to merit a trend, and if possible, analyze the source data to verify for yourself that the story checks out. As long as everyone knows that the point of Johnny's campfire story is to have fun, and it shouldn't be taken too seriously. It shouldn't be treated as verified science or history, and you shouldn't make any major life decisions based on it. The difference between campfire stories and what I'm going to be talking about tonight is that our goal at Fly Science Guy Star Shows is to inspire everyone to think like a scientist or a historian, to verify the credibility of sources you get information from, to find and understand the source data yourself, if possible, and to think critically, open-mindedly, and from as many different perspectives as possible when looking at that data. That is to say, everything I'll talk about tonight is verified history or science, and if you'd like to be too disturbed to close your eyes tonight, you can read about these things yourself after the show. All of our references are posted on our website, and I even made a post on Facebook a few hours before this show that will take you directly to that link. We could have pulled an Orson Welles and read a scary but fictional story to you, and you'd think, if that was real, it'd be quite frightening. But unfortunately, we don't need to pretend that the world has real horrors. Don't get me wrong, science has made the world a wonderful place, and many people have helped make the world a better place too. But people have also done and experienced some horrific things, both in the name of science and in the rejection of it. In advertising this show, we did our best to emphasize that this show was for mature audiences. I don't recommend that anyone under the age of 13 watch without parental guidance. And if you're someone who can only get through life by blocking out disturbing information, this may not be well suited for you either. So with that said, let's start by diving into the history of Halloween. Most people don't know this, but Halloween is an astronomical holiday. It's what's called a cross-quarter day. It marks the halfway point between the autumnal equinox, the start of fall, and the winter solstice, the start of winter. And the Celtics, long ago, they celebrated it around the same time for roughly the same reasons. Halloween has its roots in Samhain, which was a festival of the Celtic people throughout Europe, dating as far back as 1600 BC. Practically speaking, Samhain was a time of feasting, when the harvest was celebrated and livestock was slaughtered so that there was less to feed during the scarce winter months. In celebration, they had big bonfires to try to push back the coldness of winter, to bless themselves in the smoke, and to ward off hostile, otherworldly beings. It was a time when the veil between our world and the other world was said to have been lifted, allowing souls of the departed, fairies, banshees, and other supernatural beings to walk among us. Now, the fairies the Celts believed in were not dainty, sweet beings that the children's film industry depicts fairies as today. To the Celts, sure, some fairies were harmless, just playing pranks on humans with no ill will, but some fairies were malicious beings who would cause harm to humans for their own amusement. They were thought to have kidnapped infants and replaced them with identical changelings or fairy infants instead. Things like caves or fairy circles, which were just naturally occurring circles of mushrooms, were thought to be the portals through which demons and departed souls entered our world. This visit caused mixed emotions among the Celts. On one hand, it was a happy time in which they could be visited by deceased family members. They'd leave food offerings for their beloved ones and put fires in their hearths to warm the spirits of ancestors that visited their home. But on the other hand, malevolent spirits and demons were also believed to have entered our world at this time. Some people would leave offerings of food outside their homes in hopes that it would appease these malevolent beings and pardon the family from any unwelcome interactions with them. People would disguise themselves as these otherworldly beings in attempts to fool supernatural beings and avoid their attention. The presence of these supernatural beings were said to aid in predicting the future. As recently as the 18th century, this manifested as predicting marriage prospects for young ladies. In Scotland, ladies would take a handful of nuts and assign each nut the name of one of her suitors. The nut that burned, rather than popping open, was said to represent her future husband. But a less romantic interpretation is of the Druids, ancient Celtic priests, who were said to have predicted the future based on the sounds and motions made by human and animal sacrifices, and the orientation of their remains. Diodorus of Sicily wrote about this practice, saying, "When the stricken victim has fallen, they read the future from the manner of his fall, and from the twitching of his limbs, as well as from the gushing of the blood." Having learned to place confidence in an ancient and long-continued practice of observing such manners. Now, it's important to note here that much of what we know regarding the Celtic tradition of Samhain, or the Celtic people as a whole for that matter, comes from what was written about them by monks and Romans, and not the Celts themselves. The Celtic people did not have written language, so their history was passed through the generations through word of mouth. For Celtic history dating back to the time of Tyrgernmas, said to have reigned over Ireland from 1621 to 1544 BC, it's unclear whether figures, practices, and events from that time are factual or legend. Legend has it, though, that on Samhain, King Tyrgernmas set up a stone idol of a god named Crom Croach and required his people to sacrifice a firstborn child to it. On one particular Samhain, Tyrgernmas and 3/4 of his people died during these ceremonies for unknown reasons. An even earlier legend said to have taken place from 2350 BC to 1731 BC. The oppressed people called Numidians were forced by their oppressors to sacrifice 2/3 of their milk, corn, and children, until they rose up against their oppressors, resulting in only 30 out of a starting number of 60,000 Numidian survivors. That is to say, they lost that battle in bloody slaughter. Now, the Celts were initially spread all over Europe, but during the Roman conquest, the only place the Romans weren't able to defeat the Celts were Scotland, Ireland, and Britain, which is why Halloween in America flourished with the influx of Irish immigrants, and of course, where the Romans did take over became the Holy Roman Empire. Science flourished under the Holy Roman Empire, and whereas in ancient times the study of stars, science, and their divine meaning and cause were considered one interwoven study, eventually science and religion began to separate. In Alexandria in 400 AD, science was thought of by Christians as pagan, anti-Christian, and blasphemous. It was in this atmosphere that a woman named Hypatia was born and rose to become a significant academic and societal influence of the time. Hypatia was an only child and was raised by her father, Theon, himself a prominent mathematician and philosopher. This, along with his resistance against the idea of women being less than men, led him to raise Hypatia as a son, teaching her to read, write, and perform mathematics. She came to surpass her father in mathematics growing up, and eventually began teaching at the School of Alexandria. It was unheard of at the time that a woman could be a respected academic and societal force, but Hypatia was. She wrote math textbooks, refined scientific equipment, and developed a more efficient method of long division in her time there. She was a respected and admired teacher who managed to create an atmosphere of inclusion and open-mindedness in her classroom, despite the unrest and violence among Christian, pagans, and Jews in Alexandria at the time. Around 415 AD, unrest rose when the local Christian archbishop commanded followers to destroy anything that wasn't Christian. A dispute between the archbishop and Roman governor became public about these heinous acts. The governor approached Hypatia asking for her guidance, as she had made an image of herself as being wise and impartial. She advised the governor to act fairly and without zeal. Soon after, however, Christian monks under the archbishop started a riot in which the governor of Rome was injured, so the governor had their leader killed. The archbishop blamed Hypatia, claiming she was a witch whose witchcraft kept the governor from Christianity, even though the governor was actually a moderate Christian himself. When Hypatia was returning home from the university where she taught, a mob of hundreds of Christian monks in black robes took her out of her chariot, tied her to the back of it, and dragged her through the city to a church. They then proceeded to use something hard, some interpretations say shells, some say shards of porcelain, to scrape off all of her flesh. They then tore her limbs apart and burned her remains. Arguably, the scariest part of this is that the mob then destroyed her university, which many historians consider to be the end of the classical age, the end of knowledge, growth, and exploration, as Europe would plunge into the Dark Ages for the next 1,000 years. Of course, that was a long time ago, and a usual human coping strategy when we hear about something horrible is to create a division, a distinction, between our reality and the reality of horrible things. Distinctions like, that was a really long time ago, or that was really far away. But we know it's a delusion, and that if we dared to explore, we'd find modern-day realities we'd be quite uncomfortable acknowledging. Mad Scientist is a common Halloween costume. If you Google real mad life scientists, you'll mostly find past biologists doing ethically questionable experiments, or mentally unstable people like Tesla who were labeled as mad because mental health and illness were not even understood that well during their lifetimes than they are today. But you'll also find Jack Parsons, who is in a category all of his own. Jack Parsons is famous for his scientific contributions to rocketry. He was one of the founders of Aerojet Engineering Corporation, later rebranded to Jet Propulsion Laboratory, or JPL, which is a part of the California Institute of Technology that NASA manages. Now, Parsons makes the mad scientist list because of his leadership role in the sex magic religion of Thelema, founded by Aleister Crowley, who would call himself the Beast 666. But there are lots of instances of people doing scary things as a result of non-scientific beliefs, such as a mother who slit her own daughter's throats because she didn't want them to suffer when the world was said to end in 2012. The reason we're talking about Jack Parsons is because of his contributions to science. Nothing is black and white. It'd be easy enough to tell you just about Parsons calling himself the Antichrist, or leading a cult that held short masses involving a priest and priestess having sexual relations while the rest of the Thelemites watched, but that would be doing a disservice to history. Because in reality, Parsons was instrumental in pushing rocketry research forward when the field was incredibly stigmatized and the idea of space travel was regarded as fantasy. He's also responsible for making developments in the use of solid fuel for rockets. Solid fuel is like a powder or a block of powder instead of a liquid fuel like gasoline. or uh, or kerosene. Solid fuel rockets were one-time use rockets, essentially, because once you light a solid fuel rocket, it doesn't stop burning until the fuel is depleted. This is in contrast to a fuel like gasoline or kerosene that goes into a combustion chamber through tubes. So if you want to stop the rocket from receiving power, you just close those tubes. Jack Parsons developed and popularized the use of a lot of these solid fuels. And we still use solid fuel rockets today, by the way. One way they're still used is for missiles to give liquid fuel rockets that extra oomph during takeoff. Jack was very progressive and open-minded, which is why he was open to Aleister Crowley's Thelema in the first place. From a young age, Parsons was interested in magic, and I don't mean like pulling a rabbit out of the hat magic. No, I mean as a kid he attempted to summon Satan into his room. He claimed to have succeeded, but ironically stopped because he was too frightened. Today, of course, rocketry is accepted as science. That is, the study, observation, and search of explanations to how physical and natural worlds work. But back then, space travel was considered just science fiction. So to Jack, magic and rocketry had the same appeal. They seemed impossible and were both stigmatized by society as rubbish. So we don't need to embellish the story of Jack Parsons to make it fitting for Halloween. Jack faced a lot of hardships throughout his life, but he never let that hold him back. As a kid, he didn't have many friends, and he was bullied relentlessly. But he was also very bright, and was interested in explosives. When his mother sent him to military school, thinking it would be good for him, he thought otherwise, and typical Jack found an unconventional but effective solution. He got himself kicked out by literally blowing up toilets at the school. Now, if you have a science degree, chances are you've seen this poster and all the memes that it became. Jack Parsons embodied why these posters exist. Later on in his life, Jack Parsons, his childhood best friend Ed Foreman, and Caltech student Frank Molina were given the go-ahead from Caltech professor thanks to Frank Molina's connections with the university, to use their chemicals and equipment for research, which led them on a single Saturday killing a section of campus lawn by spilling a tank of liquid nitrogen tetroxide, as well as flooding the science building with gaseous nitrogen tetroxide and methyl alcohol fumes that rusted all the metal equipment in the building. After having to clean all of the equipment in that building, Caltech gave them an area on the far side of campus as a place to perform their apparently destructive experiments. Here they earned the nickname Suicide Squad because of the frequent explosions heard from the outdoor lab, garnering the attention of the student body, staff, and outside journalists. So frequent, in fact, that his crew was finally forced to move their experiments far from campus in the vast open desert, where there was less infrastructure for them to destroy. During World War II, Parsons was contracted by the government to build jet propulsion for bomber planes. But toward the end of World War II came the Red Scare, where Parsons had his security clearances taken away because it came to light that he had hung out with people associated with the Communist Party prior to the war, mostly for intellectual conversation as opposed to political affiliation. When Parsons could no longer pursue his passion for rocketry, he channeled that passion towards Thelema. Generally, the worse Jack's mental and social state, the more extreme his escapades into sex magic became. One of the things that he was trying to do was basically create an elemental, a being of a certain element like fire, water, or earth, to be his lover. He performed rituals where he believed he had to climax on a series of relics while chanting, which disturbed his roommates who, while technically Thelemites, may have really just been in it for the sex orgies, as this was the climate of California at the time. Ed Foreman, whom also associated with this cult, claimed that during these times Jack summoned banshees, shrieking female supernatural beings that are said to be an omen of death. I think, though, that this was likely a bad case of tinnitus, a ringing in the ears. Foreman continued to claim he heard banshees throughout his life, not just when around Jack, and he did work with explosives that could cause hearing problems such as tinnitus. As a part of his pursuit to summon an elemental, Parsons actually went into the desert with L. Ron Hubbard, who later founded Scientology, and masturbated while chanting, listening to opera music. During these times, Parsons documented his beliefs in writings in one of his books, The Book of Babylon, where he claims, "An end to restriction and inhibition. I, the Antichrist, am come among you, preaching the word of the beast 666, which is, there is no law beyond do what thou wilt. And I, Balaron, Antichrist, do lift my voice in prophecy and say, I shall bring all men to the law of the beast 666, and his law I shall conquer the world. And within 7 years of this time, Babylon, the scarlet woman Hilarion, will manifest among ye, and bring his work to its fruition." When a red-haired woman in a fiery red dress showed up to join the house of the Thelemites, Jack believed her to be the fire elemental that he had summoned. The two married, and after some years planned to go to Mexico to start a new life together. Him and his beloved packed up all their belongings, and Parson transferred his lease of his house to some friends, since it'd be of no use to him while in Mexico. The day before they planned to depart, Parsons got a request from a special effects company he had been creating explosives for. Parsons explained that all his equipment was packed up and that he was leaving the country in a matter of hours. But the company was insistent that Parsons help them out just one last time. Typical Parsons, he had all of his explosives stored in the shed of the house he was leaving behind. With his proper equipment all packed up, he went to the shed and started mixing up the requested explosives in an old coffee can, a move which OSHA would surely be proud of. The little boy who was part of the family obtaining the lease came to the shed to observe the mad scientist. On his way back inside, he lightheartedly said, "Don't blow us all up, Jack." Before finishing the product, the coffee can slipped from Jack's hands. He reached down to try to catch it, but as coffee cans filled with explosives do, when it hit the ground, it blew his arm and half of his face clear off. Unfortunately, Jack was still alive when they found him, but he died from his injuries later on that day. So in conclusion, wear your safety goggles. In all seriousness though, I don't want to scare you away from science. Wear your safety goggles and don't mix explosives in a coffee can in your shed. And if you read our supplementary info on Jack Parsons, I bet you'd find him inspiring, ignoring some of the personal life and haphazard safety habits, of course. But who knows where we'd be today if he hadn't studied rockets. But studying the universe makes you very aware that nothing we experience is forever. Not our lives, not the human species, not life on Earth, not Earth itself, our solar system, any solar system, galaxies even. Through science, though, not only do we know that these things will eventually end, we also have an idea how. And after learning how everything will come to an end, you can decide for yourself whether you'd prefer to live forever. I know that when people ask me if I had the option to live forever, would I always say no. And these explanations that I'm going to bring up you'll soon understand why. Because even if the human race doesn't exterminate itself or get wiped out by an asteroid like what happened to the dinosaurs, we live on a doomed planet. If nothing else kills us, what will definitely kill us is the evolution of our sun. Our sun has an enormous amount of gravity because it has so much mass, so much stuff that makes it up. This gravity pushing in on our sun causes the nuclei, the center parts of hydrogen gas particles, to fuse together, making helium. When this happens, when hydrogen nuclei slam together and become helium, a tremendous amount of energy is released, and that energy pushes outwards against the enormous force of the sun's gravity. But eventually, our sun is going to run out of hydrogen to burn. When that happens, there's no energy from fusion to push back against the force of the sun's gravity. So gravity eventually wins over. It'll press in on the core of our sun, now made of helium, until that helium starts to fuse into other elements, which, when released, which releases even more energy than hydrogen fusing into helium. So then that energy pushes back against gravity, but more so this time. So much so, in fact, that our sun's atmosphere, or envelope, grows from the outward energy of helium fusing into other stuff. At this point, our sun will be what is called a red giant star. It's going to swell, engulfing Mercury, Venus, and either getting very close to Earth or engulfing Earth as well. Before you let out a sigh of relief because the sun might not swallow Earth, once the sun is that large and that close to Earth, Earth will not be habitable. Like what happened to Mars so long ago, our atmosphere will be sheared off, our oceans will boil away. That's Earth's fate in about 6 billion years. But the Earth will begin to be uninhabitable in only about 1 billion years. And with our current technology, there's nothing we can really do about that. Now, people sometimes say to me, 1 billion years is a long time. What if we come up with a way to travel to another planet by then? But we can only avoid the inevitable for so long. Our solar system, eventually the sun, will run out of helium to fuse. But unlike when it runs out of hydrogen and starts fusing into helium, once helium is fused into heavier elements, those heavy elements won't have enough pressure in our sun to fuse further. That means once again there will be no energy pushing out against the sun's gravity. The core of our sun will collapse again. It will push inwards until the electrons at the sun's core are forced close enough together that they repel each other and push outward against gravity. Much like when you put two negative ends of magnets together and you can feel them seem to push away from each other. The outer envelope of the sun is pushed further and further outward, creating what is called a planetary nebula. A roughly spherical cloud of gas and dust that surrounds the exposed core like a quiet ghost of what used to be. The core left behind is now called a white dwarf, and this will be the fate of our sun and any low or medium mass stars less than 8 times the mass of our sun. But not all stars go out so quietly. For stars that are 8 to 25 times the mass of our sun, remember, more mass means more gravity. When stars do run out of helium to burn, they do have enough strength to fuse heavier elements. And when that particular star has fused the heaviest elements it can in its core, then the core begins to collapse yet again. The star is so massive that the gravity is so great that it doesn't care that these electrons don't want to be close to each other. This gravity collapses the core to such an extent that these electrons are now not only forced to be near each other, but forced to be closer to protons as well. So close that they essentially give their charges to protons via weak nuclear force, turning the protons into neutrons. The core becomes a dense, solid ball of neutrons called a neutron star. Now, with white dwarf stars, as I said, you have radiation that overcomes the force of gravity, gradually pushing out the star's envelope from the core, creating a planetary nebula. But with these more massive stars that create neutron stars as their stellar corpse, the point at which the core stops collapsing is not a soft stop, where the forces within reach equilibrium with the forces of gravity. No, instead, gravity slams these neutrons together. And since you can't have two objects occupying the same space, the neutrons just get as close as they can to each other, until they suddenly halt and blast a tremendous amount of energy outward. This is what's called core shock. Newton's third law of energy is that for every action there is an equal and opposite reaction. So the action of gravity slamming the neutrons together leads to the reaction of that energy having to go somewhere else once the neutrons suddenly have nowhere else to go. And since that energy can't go inward, it goes outward. An explosion of energy called a supernova that blasts the star's envelope to smithereens, creating a more chaotically shaped nebula surrounding a rapidly rotating neutron star. The shape of these nebulae are totally random, just however the dust and gas end up as a result of the core shock explosion. But they can randomly end up in some pretty spooky shapes. Like this nebula that, to me, looks like people screaming and flailing as they're sucked into a mist. Or this one, nicknamed the Witch's Broom Nebula, which was created from a supernova that occurred 9,000 years ago. Or this one, this one that took the shape of a hand reaching toward its neighboring gas cloud, shown as red. And while we're looking at nebulae, this is actually a planetary nebula from lower mass stars that can be found in the constellation Aquila. And while a telescope, it just looked like a pinpoint of light, when photographed using the Hubble Space Telescope, it's revealed that it looks like a giant eye watching the universe. So for stars less than 8 times the mass of our own sun, the collapse of their core yields a white dwarf star and a planetary nebula. For stars 8 to 25 times the mass of our own sun, the collapse of their core yields a neutron star and a supernova explosion that creates these chaotically shaped nebulae. But there are stars greater than 25 times the mass of our sun. Earlier, I said that two objects can't occupy the same place in space-time. But with these most massive stars, 25 times the mass of our sun, their gravity is so great that, in a sense, it does force these neutrons to occupy the same space. Gravity forces them to keep compressing, ripping a hole in space-time. A black hole. The amazing part about this is that once you push past that neutron point, we don't know of anything that would stop the collapse after that. So for all intents and purposes, as far as we're aware, black holes are collapsed stars that never stop collapsing. They collapse infinitely, making them infinitely dense. The gravity of black holes are so strong that not even light can escape it, which is why it appears black. If you were on a space mission and one of your fellow astronauts floated away from the ship and was pulled towards a black hole, you'd see them float further and further from you, flailing for their life until they appeared to just stop, to freeze. That moment when you see your friend freeze is when they pass the event horizon of a black hole, the point at which you would have to be traveling faster than the speed of light to escape. You see your friend freeze because our view of him has been the result of light reflecting off of him and entering our eyes. But once he passes the event horizon, the light reflecting off of him cannot escape the black hole and reach your eyes. He will eerily start to turn red and translucent, slowly fading away. But in comparison to your emotional anguish, what your friend physically experiences during this is arguably worse. As he gets further and further into the black hole, because it has infinite density, infinite gravity, the gravity at his feet is far greater than the gravity at his head, so his body is ripped in half. Then for each of those two halves, the bottom part of each of those halves has greater gravity than the upper part of each half. So they get broken in half again, so that your friend is now in 4 pieces. Each of those get ripped in half again, and this keeps happening until your friend is just a stream of atoms plummeting into a black hole. And this is a very real process that creative scientists call spaghettification. Stars form and burn and die. They create other stars that form and burn and die. But this cycle eventually ends when there's not really anything that can be used to create new stars. When this occurs, this is the downslope of the universe. The first things to go will be more massive, hotter stars, then medium mass stars. The last stars to go will be the very low mass red dwarf stars. These stars will live up to 100 billion to 1 trillion years, almost 10 to 100 times the size of our universe now. Once the age of the red dwarf star ends, however, they will also turn into white dwarf stars. And the remaining light in the universe will be from these remaining white dwarfs. Starting at this point for the next several quadrillion years, nothing new will occur. Just the faint glow of various dead remnants of former stars, laid stagnant in our universe as they grow dimmer and dimmer, eventually dying out themselves. Not in a bang, and hardly with a whimper. For an uncountable amount of years, our universe will be dark and silent. Nothing giving off visible light, nothing forming, nothing living, until the first black hole dies. Eventually, the universe will radiate the occasional light of black holes exploding, giving off tremendous amounts of energy as they do. That is, of course, until the final black hole explodes. Once the last black hole goes, our universe will only be left with the dark husks of black dwarf stars, and anything else that didn't fall into black holes. It's theorized that protons, the subatomic particles that make up all matter that we know, will also eventually decay. They'll be the last things to decay. With this, anything left will break down, evaporate until we have just a sea of elementary particles. This will be the last breath of our universe. As far as we know, nothing new will form, nothing new will end. Eventually, everything that ever existed, everything that ever happened, what's left of the universe will show no indication that anything had ever occurred. A silent husk of what once was. I hope you've enjoyed this show, and I hope you have a spooky but fun Halloween. One final note, since we do primarily give astronomy shows, I have to mention that this is a particularly special Halloween, because it is the first time in 46 years that there's a proper full moon on Halloween. This won't happen again until 2039. So hopefully you can go outside after the show for a peek at that. As I mentioned, if you want to learn more about anything I've talked about tonight, head over to flyscienceguystarshows.com for access to a complete list of resources. If you have any questions, please feel free to comment, and I'll stick around and do my best to answer any of the questions that you may have. Anything I don't know the answer to, I'll do some research and post the answers in our supplementary show info page, which will be updated with the bonus stuff within the next week. Being Halloween themed, this was a little bit different format from our regular astronomy-based shows, but if you're interested in our next show in November, will be about how to shop for telescopes, so just in time for the holiday season. If you enjoyed the show and have the means to do so, we have a donation button on our website, and your donation allows us to keep doing these shows. Our mission at Fly Science Guy Star Shows is to promote learning and understanding by making people excited to ask questions. Never stop asking questions. Never be afraid to ask questions, because there's so much that we don't yet know and so much that we can all still learn about the world and science around us together. With that said, I'll stick around for a little while, open the floor to questions, but if you're all set to go, I hope you have a wonderful rest of your evening and a happy Halloween. Did you have anything you wanted to add, sweetie?
I said that the big stars, the red giants, will go first, and then the smaller red dwarf, they would last long. If they're smaller, why do they last longer?
So it's not red giant stars that are going to be the ones that last the longest. It's going to be low mass red dwarf stars. So in astronomy, pretty much everything that is fusing hydrogen into helium, we consider a dwarf star. Our sun is called a dwarf star. It's not that red giant stars are what you get from low mass or medium mass stars that ran out of hydrogen and are fusing helium now. Red dwarf stars, however, are extremely low mass stars that will only ever fuse hydrogen into helium. So when they run out of hydrogen, they don't start fusing helium, they just turn into a white dwarf. So red dwarfs are to be understood to be separate from red giants. And because red dwarf stars are so low mass, the lower mass star you have, the cooler the star burns, the longer it lives. So any star that is extremely low mass burns very, very slowly and will be the last to go. Well, they'll be the last actual star to go. And then when they turn into white dwarf stars, which is not a star but a stellar corpse, then the white dwarf stars will be the last thing to shine in our universe. Brandon, I'm glad you found it. I'm glad you found it spooky. I was hoping that it was going to be spooky, right? Like, even thinking about the universe dying out is like kind of like how we talked about earlier, that dissociation thing. Like, it's so far away, it's like, how can that be scary? But it's like just the idea of like yeah, humans are gonna die in the next several billion years, one way or another. But it's like comforting kind of to know that like our sun might give off enough stuff to maybe make more lower mass stars. I don't know. Our sun itself is a second or third generation star, meaning that there was a star that came before our sun that was extremely massive and blew up and created other stars, including our sun. So like maybe our sun will have enough like stuff when it dies to create other stars, but that's a comforting thought, you know, like we might die, but other things might come to live in the universe afterward. But like the idea of like the universe just getting more and more dilute until it's just like a sea of basic particles that can't make anything new, like that's the end. Like nothing new comes, and it's just dark forever. There's nothing around that can experience that darkness. Nothing can survive in a universe that has no like appreciable change in energy. But it's like you won't even be around to appreciate the nothingness. But it's that kind of dissociation that makes it that I'm like, is that scary to a lot of people? Because at least the sun burning is more immediate in the scale of the universe. Her voice is so dainty, the microphone just won't pick her up. Like, so low register. But her question is, how far along are we in the scale of everything dying? We are in terms of how long all of this will take, we are in like a blink of an eye. Like, the universe has only been around for, our best estimates, 14 to 16 billion years. And our universe, by the time this is said to have died out, it's like, alright, if a billion years is like one with, what, 9 zeros after it? The time at which this last thing, the protons dying, is a number that is 1 with 60 zeros after it. So, the universe, if it was like a human child, has like just popped out of its mother in terms of how old it is. How are scientists able to predict what's going to happen? Are black holes the oldest or most long-lasting objects in the universe that we know of? So, scientists are able to predict most of what happens here with models based on how we've observed the universe so far. The idea of black holes even dying was thanks to Stephen Hawking, who was one of the leading people on black holes. And it fittingly, black holes decaying is from a process that involves something called Hawking radiation, named after Stephen Hawking. And it's this idea that through quantum mechanical processes, there is a little bit of energy that escapes black holes. And so whenever something is giving off energy, even if small amounts, it means that it will eventually die out via thermodynamics. But yes, they will be the oldest, or, well, yes, not counting protons, they're going to be, well, no, I guess, because, like, eventually black holes will die out. So technically, anything that's not radiating energy anymore is going to be the longest living. But then you have to define what the longest living, I guess. Yeah. So there are primordial black holes. They're black holes that formed just from the energy of the Big Bang itself. These are smaller black holes that will probably, that will probably die out sooner than these more massive black holes. The black holes, I do want to state one thing as well, clarify something. Black holes themselves are not going to be the last things to die. Supermassive black holes are going to be the last thing. Because you can have super itty-bitty microscopic black holes that, because of Hawking radiation, just kind of dissipate immediately. With black holes, it's kind of the opposite of stars. The lower mass the black hole is, the faster it dies from Hawking radiation. So the last things to die is going to be supermassive black hole, like black holes at the center of galaxies. Now, with protons dying, there's protons decaying. That is something that is not exactly proven physically. We've never seen a proton decay because its half-life is, again, 10 to the 60th years. But some newer models that try to make a grand unifying theory, bringing everything together, requires the idea of particles or protons decaying. So it's not physically proven yet that they will decay, but if they do decay, that's the process. That's what's going to happen. If they don't decay, then our universe will just be a sea of whatever didn't fall into a black hole, like brown dwarfs, black dwarfs. Also, black dwarfs technically haven't been proven either, because the time frame that it takes for a white dwarf star to cool off so much that it doesn't radiate anymore is also longer than our universe has been in existence. So that's more of, we know that will happen because of thermodynamics and how we experience things on a small scale. So, in short, we know these things are going to happen because of observations we've made of things on small scales that we can apply to big scales. And some things are just, they're not proven, they're just mathematically proven or suggested. So, black and brown dwarfs. Brown dwarfs are essentially like Jupiter. They are massive gas giants that just didn't get massive enough to begin fusion. The idea of planets and stars being different is mainly for ease of understanding and the fact that humans like to have things categorized. In reality, planets are just failed stars as well, like terrestrial planets. Like if you start out with the smallest asteroid and it gains more and more and more and more mass, you'll eventually get something like Earth. And if you give it more and more and more and more and more and more mass, then it gets a huge magnetic field and it begins to get a huge atmosphere. You give it more and more and more and more and more and more mass. Eventually, there's so much pressure that this what we would call a surface begins to kind of break down because heat and stuff heats it up and it turns into a gas or a plasma, and you get something like our gas giants like Jupiter, Saturn, Uranus. You put more and more and more and more and more and more mass into it, you get something that would be massive enough to begin nuclear fusion, so then you get a star. So everything we experience in the universe is just different stages of the same thing. And a brown dwarf is just one of those bodies, like Jupiter, that has more mass to be almost as massive as low-mass stars, but not massive enough to begin nuclear fusion, which is what stars do to create light and heat. Black dwarfs are when you have a star, medium or low-mass star, that dies out, and it turns into a white dwarf star, basically just leaving the core behind. That white dwarf star, that corpse of like what our sun will leave behind, that will burn for trillions to quadrillions of years, but eventually the white dwarf will lose so much energy that it doesn't glow anymore, and so then it'll just kind of be analogous to a brown dwarf, something that isn't fusing or isn't creating light. So brown dwarfs are just objects that didn't become massive enough to be stars, and black dwarfs are basically the corpses of the corpses. They're what white stars used to be, but are just no longer glowing. Well, I think with that, we'll go ahead and end the show. I hope everyone enjoyed themselves. If you do have other questions in the future and you either didn't get to ask them or kind of, I know there's the stigma around just like when people have gone to school and stuff, and maybe you were one of those kids who was afraid to ask questions because they didn't want to look dumb, which I assure you I don't, is never a thing. I love when people ask questions, and there's never such thing as a dumb question. But if you still feel like you want to ask questions in private, you can go to our website, flyscienceguysstarshows.com, go to the contact page, and you can send questions and include your email so that you can, and then I'll email you back with the answer and possibly some resources. And if you have suggestions for the show, there's also a place in the contact page for you to send anonymous suggestions as well. If you liked something, didn't like something, preferred something different, whatever. But thank you guys so much for coming, and have a wonderful rest of your Halloween.